Hi, good day dear audience. Today I want to present how to solve such a differential equation. Behold this equation. I hope no one would tell me this would be solved by partial fractions. Partial fractions is applied only when the expression in the numerator and the denominator is made up of the same variable with different degrees, x squared plus 2x plus 5 or 3x cubed plus x squared or whatsoever, but made up of the same variable. Here we have two variables, one x and one y, and the differential is dy by dx. So what would we do? Another condition to apply partial fractions is when the numerator is of a degree less than the truly you could tell me that the numerator here is of 0 degree while the denominator is of the first degree, but it is made of two different variables, x and y. So here we cannot apply partial fractions. Let's start to solve it. The first thing we would do is to assume or put 3x plus 2y equals t and solve for t, as we'll soon see. So here we'll differentiate this expression, the assumed expression 3x 3x by dx, that is 2 plus 2 dy by dx equals dt by dx. And to apply in this equation, so we have 2 dy by dx equals dt by dx minus 3, which result in dy by dx equals half dt by dx, and dividing both the left hand side and right hand side of the equation by 2, we get dy by dx equals half dt by dx minus 3 over 2 to get pure dy by dx. And substituting for the value obtained by dy by dx, and let us call it 2, in the given expression or the given differential equation, we get that half dt by dx minus 3 over 2, which is equal to dy by dx, equals 1 over t plus 5, because we assume that 3x plus 2y equals t. And let us proceed here. Half dt by dx, look at this line first, half dt by dx minus 3 over 2 will transfer the minus 3 over 2 on the other side with positive sign, so we get half dt by dx equals 3 over 2 plus 1 over t plus 5. And let us take the LCM of the left hand side. We get half dt by dx equals 3 into t plus 5 plus 2 over 2 into t plus 17, 15 plus 2 over t plus 5, because multiplying by 2 this 2 vanishes. Okay, so dt by dx equals 3t plus 17 over t plus 5. And by cross multiplication we have t plus 5 dt over 3t plus 17 dt equals dx by cross multiplication. Let's call this lambda. Here we have to use substitution for the second time. Here to solve this integration, but the first time we used a substitution to get rid of the y by assuming this whole quantity to be equal to t. Here we have to resubstitute, and then we resubstitute once more after integrating. Here we have, as you see, dt by dx, as we have just said, 3t plus 17 over t plus, by cross multiplication, t plus 5 over 3t plus 17 dt equals dx. And we can put here to make the denominator made of just one term to be able to perform the integration, we put 3t plus 17 equals p. And as a result of, we would have, and differentiating this quantity with respect to p, we get 3 dt equals dp. This is a constant value, so it is differential is 0. Or other words, dt equals dp over 3. Let's call this equation 1. And here, from our assumption 3t plus 17 equals p, and to be able to substitute in this equation for the equivalent values of, we have t equals p minus 17 over 3. 3t equals p minus 17. So here let's call this 2 from 1 and 2 in lambda, we get that t plus 5, that is p minus 17 over 3 plus 5 over p, which is 3t plus 17, dp over 3, which is dt, equals the x, which results in p minus 17 plus 15 over 3. Taking the LCM here, 3 and 5, that's plus 15 over p, dp over 3. And multiplying both the numerator and the denominator by 3, here multiplying by 3, the 3 vanishes. We'll be left only with p minus 2, p minus 17 plus 15, that's p minus 2, over 9p dp equals the x. Or other words, that's why we have substituted, to be able to make the denominator made of one term and the denominator made of one term and the numerator made of two terms. So here we have p over 9p, that's 1 over 9, 2 over 9p. So here our integration becomes the integral of 1 over 9 minus 2 over 9p dp equals integral dx, which after integration 1 over 9 dp becomes p over 9 and 2 over 9p dp becomes 2 over 9 ln p equals x plus c, constant of integration. Now we go backwise. Integral dx equals x plus c. And now we go backwise because our given wasn't in terms of p, was in terms of x and y. So we resubstitute first and to go, as I said, backwise to get the relation between p and t and then the relation between t and x and y. First of all, we should remember that we assumed that p equals 3t plus 17. So here we have p over 9, that's 3t plus 17 over 9, minus 2 over 9 ln 3t plus 17. And backwise once more, we resubstitute backwards to t in terms of x, y. We assumed our first assumption was, that was our second assumption. This was our first assumption, t equals 3x plus 2y. So we resubstitute once more 3 into 3x, we substitute for t, 3 into 3x plus 2y plus 17 over 9, minus 2 over 9 ln 3t, which is 3x plus 2y plus 17 equals x plus c. And having all the denominator 9, we expand 3 times 3x, 9x plus 2y times 3, 36y plus 17. This is out of bracket. 2 over 9 ln 3 into 3x plus 2y. That makes 9x plus 6y plus 17. That's out of this bracket. Equals 9x plus c. Of course, this c in this equation just 3 times, sorry, is just 9 times in the first, but let us see, that's constant of integration. And this is our solution here. The solution of our differential equation takes this form: 9x plus 6y plus 17 minus 2, that's plus 15. Let's if you want to write it, sorry, plus 15, okay, minus 2y ln 9x plus 6y plus 17 equals 9x plus. So here in this step our equation reduces to 9x here on the left hand side, cancelled with the 9x on the right hand side. So we are left with 6y. 17 minus 2 makes 15, so we have 6y plus 15 equals, we transfer this quantity to the right hand side being with negative sign, so we will have 6y plus 15, 17 minus 2 equals twice ln 9x plus 6y plus 17 plus c. So our equation reduces to 6y equals twice 15 and c reduced because they would vanish during differentiation. So our equation reduces to 6y equals twice ln 9x plus 6y plus 17 plus c, assuming that the c includes the 15 and the c. Never mind. Here is 6y and here this the right hand side of the equation is multiplied by 2. So we are left with 3y equals ln 9x. 6 divided by 2 makes 3y equals ln 9x plus 6y plus 17 plus c. We could have omitted the c, but it's better because on differentiation it will yield 0 because it is a constant term. Okay, so this is our solution. And this equation, this type of equation, you won't find it except in very few books, and its integration is really interesting and unique. I hope I have introduced something new. And now, my dear audience, let me say good day and goodbye.